Good afternoon, students. So today I am going to solve one more problem on homogeneous linear partial differential equation with constant coefficient. Okay, so homogeneous linear partial differential equation, or simply I write PDE, linear partial differential equation with constant coefficient. So in the last class I have solved only one problem on this. Let us start today. Let us solve one more problem on this. Okay, so here the problem is solve d square minus d dash square plus 3 d dash d square minus d dash square plus 3 d dash minus 3d into z, into bracket z is equal to e raised to x plus 2y plus xy. Okay, so this is the given problem. Now we find the solution for this. So first we write the auxiliary equation. So auxiliary equation is, so this is the auxiliary equation. Write that d square minus d dash square plus 3d dash minus 3d equal to 0. Okay, so here it is a second order equation. So here we find the roots. So here there are two roots. So we find the roots. So here this cannot be solved either by factorization or by applying the formula now. Okay, so what we do, we find one root by inspection method, and other root either by dividing the given equation by factor, or you can apply synthetic division method. So here on observing this equation, I feel that for put d is equal to d dash in this equation. So what happened on substituting d is equal to d dash? This gives d dash square minus d dash square, then plus this 3d dash as it is. Now here I have to replace d by d dash. So minus 3d dash, which is equal to, now d dash square get cancelled, 3d dash get cancelled. So it will give 0. So for d is equal to d1 d dash, so we are obtaining this equation satisfied, right? So therefore one root is d is equal to d dash. So now the corresponding factor for this is d minus d dash is equal to 0 is a factor corresponding to this root d dash. Okay, so now we find another root. So to find another root, what I do, I divide this equation. That is, this is d square minus d dash square plus 3d dash minus 3d, right? So I divide this equation. So I put this line, then I take here d minus d dash, right? Now I multiply this equation. So I want to cancel this term. So what I do, I multiply this with d. So d square, then d into d square minus d dash minus d dash, right? So now this plus minus, this is plus. Okay, so this plus d dash square minus d dash square get cancelled, and I write this one as d dash minus d dash square, then this plus 3d dash minus 3d, writing the other two terms. Okay, so now, so again I have to multiply this d dash. So here I have to cancel this d dash term. So what I do, I multiply with plus d dash here. So multiply here this d dash, d into d dash, d dash minus d dash into d dash minus d dash square, then plus, okay, only two terms, right, d dash, d into d dash, next minus d dash into d dash square. Now again I simplify this. So this minus, this is a plus, this will cancel and this will also cancel, and I left with 3d dash minus 3d. Okay, so now I have to again apply the same technique here. For that, what I do, I multiply with 3, d dash plus 3. So I multiply here 3d minus 3d dash. Okay, so now what I get, this 3d dash plus 3d get cancelled. Now this is the remainder is 0. So another factor is what, d plus d dash plus 3, d plus d dash plus 3 I got. Okay, so I multiply this 3 into d dash minus 3d dash, okay, correct, minus 3d dash, then plus 3 into d plus 3d. So therefore d plus d dash plus 3 is another factor, So therefore what I say, the total, our original auxiliary equation, d square minus d dash square plus 3d dash minus 3d is equal to the multiplication of these two factors, right? Multiplication of the one factor is d minus d dash and another factor is d plus d dash plus 3, d plus d dash plus 3, these two. Okay, so now what I do, I find the other two roots. So this gives, so first factor equating to first factor. So this is the first factor. This is the first factor equating to 0. So d minus d dash is equal to 0. That means d is equal to d dash. Now substitute this value, d is equal to d dash. Now substituting d is equal to d dash in the next factor. So that is what? This factor. So in d plus d dash plus 3 equal to 0. So what I get? D means d is equal to d dash plus 3 is equal to 0, or 2d dash is equal to minus 3, or d dash is equal to minus 3 by 2 I get. So when d dash is minus 3 by 2, then substitute this value of d dash in this equation. So you will get d. So similarly d is equal to minus 3 by 2. So I get d dash is equal to minus 3 by 2, and also I got d is equal to minus 3 by 2. Both are same roots. Therefore two equal roots we are getting. So therefore the solution is, our complementary function is equal to it is equal to f complementary function is equal to, since it is the two roots are repeated, so therefore the complementary function we have so it is repeated. So e raised to, this is equal to e raised to minus 3 by 2, into f1 of y plus y minus 3 by 2 x, then plus we have to multiply with x, e raised to minus 3 by 2 into f2 of y plus means y minus 3 by 2 x. So this is the complementary function. This is the complementary function because the two roots are repeated. Therefore we take this for. So therefore this is a complementary function. Next we find particular integral. So particular integral is equal to so pi is equal to, so 1 divided by, again we take the same factor, d minus d dash. Already we factorized that, d minus d dash into d plus d dash plus 3 of the first term is equal to that is e raised to x plus 2y, then plus e raised to x plus 2y, then plus xy. Okay, so this is a particular integral. Now we find the particular integral. To find the particular integral, so what we do to find the particular integral? So first operate this one on this, that is equal to 1 divided by d minus d dash into d plus d dash plus 3 of e raised to x plus 2y, then plus 1 divided by d minus d dash, okay, into d plus d dash plus 3, which is to be operated on the next term, that is xy. Okay, so now we find the first, consider this one. Okay, first we consider the first particular integral. So this gives, so now consider the first one. Consider the first pi, that is 1 divided by d minus d dash into d plus d dash plus 3 of e raised to x plus 2y. First we find the particular integral of this term, and then we go to the next term. So which is equal to so now here we split this. Okay, we split this as e raised to x into e raised to y, e raised to x into e raised to y. So what I do, so this can be written as 1 divided by d minus d dash into d plus d dash plus 3. So here I will split this e raised to x into e raised to 2y. Okay, so now what I do, I take this e raised to x outside this operator. So when we take e raised to x outside this operator, here what happened, this d, only d is replaced by d plus a means here x coefficient. Here x means what, this x can be written as 1 into x, correct? So 1 is multiplied with x, so that means this a is equal to 1. Okay, so this is what, this is a, this a is equal to 1. So while taking e raised to x outside the this operator, I replace d by d plus a means 1. So okay, so I take e raised to x outside the operator, then here I replace d by d plus a, so d plus 1, then minus d dash as it is, into here also I replace d by d plus 1 plus d dash plus 3 as it is, then I write remaining the term e raised to 2y, okay, e raised to 2y. So then this gives Okay, this is one way. Okay, next another way is what you can take, or just one rule is there, directly you can do that, but another one rule is what, so just replace d by a and d dash by y's coefficient, right? So instead of doing this, okay, so instead of doing this, simple way is that what I do is, here I write this one as it is, and here I replace d by x coefficient. So here 1 into x, this is 2 into y, so this is a and this is b. Okay, so here I will write this is b and this is a. Okay, so this 1 is a and b is 2, so this can be written as 1 divided by, I replace d by a, that is 1, then minus d dash is nothing but what, 2, so 1 minus 2, and I write this one as it is, d plus d dash plus 3, so e raised to x plus 2y. Okay, e raised to x plus 2y. Now which is equal to, this becomes 1 minus 2 is minus 1, so minus 1 divided by d plus 3 of e raised to x plus 2y. Okay, e raised to x plus 2y. Okay, so this is equal to, again what I do, I replace this is 1 into x and this is 2 into y, so this one is a and this one is b. So again I replace the same d by a and d dash by b, so which is equal to 1 divided by, or minus 1 divided by, d means 1 plus d dash is 2 plus 3 e raised to, this is x plus 2y as it is, x plus 2y as it is. Okay, I replace d by a, this is a, and d dash by b, b means it is equal to 2. Okay, and here I will write, so 1 plus 2 plus this 3, here minus, then e raised to x plus 2y as it is. So totally you will get, this is equal to minus 1 divided by 3 plus 2 5, 5 plus 1 6, e raised to x plus 2y. So this is a particular integral for the first term. Okay, next we consider the second one. Okay, so consider the second one. So now second one, consider particular integral of 1 divided by d minus d dash into d plus d dash plus 3 of xy, correct, of xy. So here it is an algebraic function, this is an algebraic function, xy is an algebraic function. So when xy is an algebraic function, always what we will do, so this, in this denominator we take here one, we take constant term, okay, and we take constant term common, and also one operator, that is d. Okay, we common that, both will take common. So here from this we take 3 as common, and from this we take d, capital D as common. So this is equal to 1 divided by, here I take d common, and in bracket this is 1 minus d dash by d is left, and here I take 3 common, so I will get d by 3 plus d dash by 3 plus 1 of xy, correct. So in both the terms, this 1 by 3d, totally 1 by 3d is outside this integral sign, this operator divided by 1 minus d dash by d. Okay, then d plus 3 plus d dash by 3 plus 1, which is of xy. Okay, so like that we obtain. So next is this, I write 1 by 3d as it is, this implies, okay, I write 1 by 3d as it is. Next I take these two terms in the numerator, so what I will get, this is 1 minus d dash by d whole raised to minus 1, and this is 1 plus d by 3 plus d dash by 3 whole raised to minus 1, and which is to be operated on xy. Okay, so now we have one formula, that is 1 minus x whole raised to minus 1 can be expanded as 1 plus x square plus x cube and so on. Similarly, 1 plus x whole raised to minus 1 can be expanded as 1 minus x plus x square minus x cube and so on. So using these two formula, we have to expand these two. Okay, we have to expand these two terms. So that is which implies 1 by 3 into d. Now expanding this, 1 plus x means this d dash by d plus x square, that is d dash square by d square. Okay, and so on. Similarly here 1, okay, 1, then here minus x, that is minus d by 3 minus d dash by 3, 1 minus x, then dash dash dash. Now don't consider the next higher term, because what happened, next higher term means what, d square and d dash square. So d square means what, differentiation with respect to x, right? Differentiation with respect to x means here see the power of x. What is the power of x? The power of x is only 1. Okay, power of x is only 1. So if you differentiate 2 times, means if you differentiate more than the power of this x, then it gives 0. Means if the power x is equal to 1 and if you differentiate 2 times, then the differentiation gives 0. Correct? So similarly, therefore what I do, I neglected the next terms, that is d square and d dash square. D dash square means what? A differentiation with respect to y. So here d dash means here the power of y is also 1. Power of y is also 1. So therefore second time differentiation of y is also 0. Okay, so therefore I am neglecting what? The second order derivatives. So into xy I'll write, or which is equal to this 1 by 3d as it is. Now operating on one term by term. So 1 into 1. So this gives, first I multiply these two terms. First is okay, so here just see this one. First operating this on this one. So what I get, I write this one as it is, 1 minus d by 3 minus d dash by 3 minus d dash by 3. Okay, 1 minus d by 3, then minus d dash by 3, and simplifying plus d dash by d, then plus d dash by 3, then plus 2d dash by 9, and so on. So multiply these two factors, this into this into this, then operate it on xy. Okay, operate it on xy, which gives 1 by minus 1 by 3d of 1 this is xy, then plus y by 3, then plus x by 3, then plus x by d, plus x by 3 plus 2 by 9. Okay, plus 2 by 9. Okay, just multiply these two terms, multiply these two factors. So 1 into 1, then 1 into d by 3, then 1 into d dash by 3, then similarly d dash by into this one, then d dash by d into this d by 3, like that multiply, and we'll get this factor, and then operate this on this xy. So 1 into xy, that is xy, d by 3 into xy. So d by 3 means 1 by 3 is constant, d means differentiation with respect to x. So differentiation with respect to x means y is constant, so it only y will give. Okay, similarly we differentiate d dash by 3, it gives x by 3. So like that we differentiate term by term and we obtain this equation, and this is what, minus 1 by 3 d. So this 1 by 3 is constant. Next 1 by d means integration. d means differentiation with respect to x, 1 by d means integration with respect to x, then integrating with respect to x. So finally we get the term as pi is equal to f1 of y plus e raised to minus 3 by 2 x into f1 of y plus y minus 3 by 2 x, then plus x into e raised to minus 3 by 2 x into y minus 3 by 2 x, that is f2, sorry, f2 of y minus 3 by 2 x. This is a complementary function plus particular integral. So particular integral is equal to the first term of particular integral is y e raised to x plus 2y minus 1 by 3 into x square y by 2 plus xy by 3 plus x square by 2 plus 2x by 9. So this is the complete solution of the given differential equation. So with this I conclude this class. Thank you.